Today we are going to review basic R, and then we are going to using a case study to learn how to use R to load data, manipulate the data frame, and then do some simple exercise. Oh, I see. I can send the link to Dr. Liang. Do you need the link? Email, right? Yeah, on the chat window. Oh, you mean the? Oh, you don't. Can you join? Yeah, I don't think I can join it. Yeah, can you join the Zoom? I can. I will send that to the chat window. Yeah. So first, let's review the simple R exercise. Last time I go over the RMD file, the R Markdown file. For a quick review, I prepared the Collab version. So let me put that in the chat window. Okay, so you probably have to clone that into your R Collab. So the way to clone that into our Collab is, so you have to go over the R code. Oh, I see. Just go to your Collab site, and then you are going to upload from your my link, and that's just copy paste that link there, and you will have that in your Collab. I think I can also share that link. Okay, so copy that link. I can also put that link in a shared window, so you can on the Collab you can also, but you need to clone it and then run it. So this is just the Collab version of Simple R. So it has text cell. It also has a code cell. And the code cell, if you click on the play button, you can just run it. So that's the simple arithmetic, minus, division, multiplication, addition, assignment, length function. So that's very, and this is just, we can also use the assignment, use the left sign arrow. We can use print. And remember the pound sign in R is the comment. And the upper carets is the power. And smooth parenthesis for function. And the square bracket is for indexing a vector. And use help or question mark, look for help menu. A simple plot. So there, it's a quick review of what we went over last time. There's a question, is this the same? Yes, this is just Collab version of Simple R. This is, since I'm going to review that, so I don't want to repeat it. I just try a different version. Okay. So, all right. So now with that refreshment, so this time we are going to do something useful. Right. So that the Simple R seem to be interesting, but it's really not a useful exercise, I guess. It's not a real world example. So for today's exercise, we are going over the real data set for using R to analyze COVID-19 data case. So I give you a zip file link here. And if you download that zip file, 11 Mac. So if you download, yeah. So on the Mac, if you download that, you should see a zip folder expand automatically. On PC, you would have to extract it manually. So once you download, make sure you fully extract them. In this case, in my case, there I have this folder downloaded, one start R with COVID-19, and then there's a code. There's an R Markdown file, say learning R through Johns Hopkins COVID-19 data analysis. That's the file we're going to use. Okay, before I move on, let me go back to my Socratic. Okay, so 20 students, there are actually more than 20 students. And please sign in. Okay, so I have to move forward and you can sign in later. So your full name. Okay, this is just to see how many you start to work on homework. Have you started to work on data camp learning modules? That's for the assignment.
Can you send us the password again?
Password? What password?
For
Hong Chin.
There's no password.
Yeah, the room. Okay, I got it in the chat.
Okay. Yeah. Yeah. Have you started work on data camp right now? Okay, very good. Just one or two students, actually just one student. 1 out of 25 at 4%. Okay.
So we just gonna submit a screenshot showing that we completed the course, the training, right?
I think so. Although your screenshot will have your name or other information, right? You cannot just submit anyone's screenshot. Yeah, you should have your own account information there. So.
Okay.
Yeah. So this is also just see how you like a data camp assignment. On a scale of 0 from the poorest to 10, the perfect score, how do you read your current experience with data camp assignment? This will be just for curiosity, I guess. Oh, not bad. If I were data camp, I would be really happy with this customer's review, I guess. It depends. I don't know. Yeah. Let's say that I don't run data camp. So. Okay, very good. So, but it looks like some of you don't really like it. Well, average, I guess. 6 is still above average. Okay. Have you installed R and R Studio on your own computer? It's just if you have not done so, then we won't be able to move on, right? So if we have to use the R or R Studio Markdown, then we'll have trouble. Oh, very good. So, all right. So this, there's one student still said no. Then, yeah. So you should really do that as quick as possible. So yeah. Okay. So well, by now you should download that and then open. And if it's not automatically open with RStudio, you should right-click and then say open with RStudio. In my case, I already opened one version, learning R through John COVID-19. Oh, let me increase the font. I already have this version open. So. And this is what we are going to go over today. So. That's the file learning R through Johns Hopkins COVID-19 data analysis. You should actually see, you can actually see the file name on my screen as well. So. Okay, so there are 3 chapters in this exercise. The first chapter is just do a very exploratory, see what the data set look like. The second chapter is examining the daily cases, and the third chapter is to overlay Google Mobility with the COVID-19 cases by location. So today, my plan is today just go over chapter 1 with just 1 hour. That's actually already pretty tight. So the learning objective, basically, the learning objective of this exercise is to load a tabular data, in this case, a CSV file we downloaded directly from GitHub, and then use a data frame to manipulate, explore this data set. And then we can all try to summarize the content and identify the content, sort, basically so-called data wrangling using this, using R. Okay, so that's the learning objective. And first we will load the necessary libraries. Okay, before I move on, I'm going to go back to Socrates to make sure people are following. So, okay, let me open up a question. So the question is, have you followed about the RMD file in RStudio? A is yes, B is no. So A is yes, B is no. Okay, well, I guess 14 students has opened the file. That's actually pretty good. All right, so then I go back to my RStudio file, 18. And I'm going to load the library. In this case, we are going to use tidyverse. That's for data frame manipulation. We also need lubridate. That's for data and time manipulation. We're also going to use reshape. This is package to rearrange a data frame for plotting. And we are also going to use ggplot2, and dply is also for data manipulation. And officially, that should be now part of a tidyverse, but I kind of had a habit just call it again. I was told if you remove that, it should also work. Because now it should be part of a tidyverse. So, okay, so we are going to see this green play button. If we click that, it should now run. It should now run the package now. So. Oh yeah, it's actually run the other one. So. Okay, then we are going to load the actual data set. So where is this data set? This is the Johns Hopkins COVID-19 data set. It's an open source one. It's on GitHub. So if you Google this directly, JHU COVID-19, actually Google seems to official automatically prompt. That's the COVID-19. Yes, that should be this data set. Let's check. So GitHub roles, yes, already send the data. Daily physics time series. Yeah. In fact, the data set, let me see which one I use. Time series COVID-19 from the US. This is the data file we are trying to read. The way we can read is actually using something called view raw. And that basically is the URL address we are using. At the top, that's the, if I copy paste that back into my R file, see whether it is the same or not. Does it look like the same? The raw.content. Yeah, it doesn't look like the same. No. In any case, we are going to run the code. This actually takes a minute or two. Yeah. So we loaded the data. So you can actually on the right-hand side, oh, I see this, the window block that one. So on the right-hand side, you now see the table. It actually have 342 observations of 519 variable basic columns. So if we click on that, it's going to basically, this is basically a spreadsheet. So it had the, what this means, they are 42 rows. Is really a lot. If you scroll down, you should see about 3,342 rows. And that's basically how many counties. And although it's actually more than that because there are some non-county outside. There are several thousand counties in the United States. And then if we scroll to the right, you see those are the columns, ISO, FIPS. Apparently that's just the US Census code. I don't know what those means, I just use it. And then you can see that's the state, Alabama. This will be admin 2, that's basically the county name. The country is the US, and latitude, longitude, combine the key. This is actually is the key we are going to use because this means they are the county name and the state name and the US separated by the comma. And if you will scroll all the way to the right and see, and that's the first day, January 22nd. That's the first day US, or at least Johns Hopkins start to collect the COVID cases. So apparently it has been more than 500 days now. 500, how many? 590, 570 days, some days there now. So if you scroll all the way, oh, sorry. Okay. So in fact, if I scroll all the way to the very right, and that would be The Apple trying to be too smart. August 17th. Oh, this is actually not really update. August 17th. Are there still more? Oh, there are still more. August 22nd. Oh, wow, is that yesterday? August 22nd. Actually, all the way, it's kind of update. So up until yesterday, the data are still there. So, yeah. Okay, this is actually quite impressive. So we are almost doing a real-time analysis on this. Yeah. So, in fact, you can actually generate a dashboard and do a plotting on your own if you really want to do this. So, but there, that's the data set we are going to use. So what we have been loaded this data into what? What is TB? TB is the so-called data frame. So if the way we can check the data type or variable type in R is using the str function structure. So yeah, this is actually a table, which is a special version of a data frame. Its data frame is actually the old name. Tibble is actually tidyverse's name. So, okay, so this is, we basically put using the data frame to install the spreadsheet. So you can, a data frame, you can just think about the Excel spreadsheet. Except in R, the data frame actually require each column has to have a homogeneous data type. But in Excel, you can type a lot of weird customer stuff. You can put a figure there. You can add a letter in one cell, put a number in another cell. But in R, the data frame has to be, each column has to be a homogeneous data type. So there's a difference between the R data frame and the Excel spreadsheet. The Excel spreadsheet is more flexible for heterogeneous input. But the R data frame, because it's used mainly for analysis, it has more stringent criteria. It requires a column to be a homogeneous data type. So, okay, so in fact, you can actually see UID is actually treated that as a numerical number. ISO2 US that has treated a CHR char, which is character. That's a character type. How many of them? 1, 2, 3, 342. Remember, R started with the 1. So there are 3,042 rows in the first column. Because R also requires data frame is homogeneous. So every column has precisely the same number of rows. So all the rows, all the columns have the same number of rows, 342 rows. So, and this is just the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First 10 columns. Right? We can actually look at more columns later. So you can, well, it actually treat FIPS as a numerical. I guess it's okay. But it's treat the county name as a character, state as a character, and latitude and longitude as a numerical. That seems to be make sense. So R is pretty smart. It actually automatically parses the data set to a certain degree. Right? It didn't treat the US as a number. I mean, probably give an error. So, right. So it's actually R is pretty reasonably smart. Yeah. Although sometimes it's still not as smart as a toddler, but this is good enough for us, a good starting point. Okay, so now we have this in a data frame, and we can now so-called explore this data set. We can index it, right? So in the Excel, if you go back to the spreadsheet, you can browse it. But what if I tell me what's in row 100 and column 99? That would be really hard for you to browse it, right? So you have to count row 100, column 99. So there's a difference between browsing using GUI and writing a code. Writing code, you can ask computer to do something precisely you want to do. But using GUI, it may think easier, but it's actually hard for you to do data analysis. Right, so in this case, if I want to ask you, right, so this case, I want like the question is, found out what actually here I actually give the answer. That's pretty bad. I forgot to delete my answer. Okay, so what's in say 100th 100th row and 99th column? Okay, how about this? If we want to, oh, I see. I need to dim the light. Even though there's two of you, but let me still dim the light. Otherwise, it's really hard. Okay. Make it a little bigger too. So, so the question is, how do we find out the 100th rows? And let me also go back to my Socratic. So you can type your answer. This is multiple choice. Okay, so the question is, you can type your answer there. The question is, how do we find the row 100 and the column 99? And you can put your answer there. So question. What is the 100th row and the 99th column? What's in the, I guess, what's in the, oh, I see. You need some people have trouble to organize. You need to install the package. If you are the first time running R code, you have to first on the R Studio, you can click Tools, then say Install Package. So then you can install the necessary package. Yeah. So let's see what's the, is it 0? Well, I guess 0 is probably correct. I'm looking, that's actually, it's probably correct answer to, let's see, 100. Yeah, it is a 0, is it? Maybe 199. Yeah, it is 0. Okay. And we can also, what if, so from 100 to 100, 05 row and 99 to 100th column. So let me open up a new question. So you can type your answer in another question. Someone is really fast.
Could you please unveil the question again?
Oh, the question here. Let me also copy paste the question in the chat window. So the question, what is the 100th to the 105th row, and 99 to 100th column? So, Yep, I put the question in the chat window. Okay, let's see. Column is the right syntax. Hyphen is wrong. So comma, very good. This is many of you did it correct. Yeah. So those I think those should be correct answers. So TB, did I say 100 to 105, 99 to 100? So what's there? 00, 11, 00, 16, 78, 22, 24. Yeah. So, and this will be really hard to find if you look on the browser. So, but we can actually just take it out using a line of code and find this one out. So, okay, so this is indexing. It looks like the data camp is really useful. Yeah. So this should be some basic. Hold on. What can you show us again? What is that? Oh, someone typed the answer. Yeah. So okay, very good. So yeah. So.
I have a question. How did you open the tab on the R to show the data?
How do you open the tab? Oh, I see. You can just double click that. Double click on the variable in this case. So if I close it and you just double click that, or maybe single click is enough. Yeah, it looks like single click is also working. Yeah.
Yeah, it works. Thank you, sir.
Sure. Yeah. Okay. Okay. So number is okay, but we can actually use column name as a more meaningful way to indexing. Okay. So remember there are dates. What if I want to look for the dates? I don't remember the column name, right? So what if I want to look for the state? I really don't know what the row name, right? So we can actually use a more meaningful name to index rows and columns. And in this case, because of data, only column has a meaningful name. The rows is just 1, 2, 3, 4. So in this case, the data come with just the numerical row number, but the column name is actually meaningful. So if I want to say look for column 5 and name, I look for only for the FIPS admin 2 or province and state. I can just remember the C concatenation or put the vector there. Then we can specify, we can just looking at these 2 rows and the 3 column FPIS. Admin 2 basically means county name. So if I run this code, yeah. So that's actually is 2 counties in Alabama. But what if I want to put, let's say which day we want to look at it? 4th of July, 2021. How about this? We want to put July 4th, 21. Yeah. So this is more. So the difference between coding and GUI is, if you know what you are looking for, coding is much faster. That said, if you don't know what you are looking for, GUI is much more informative, right? You can just browse through without looking at the technical detail. So, but once you know, is it issue? It is okay as long as you can see the. So the RStudio has some output configuration. You can actually configure where you put that output. It's either inline or in terminal or both, but you can also control where you put in the output. Yeah, so it will show up on chunk is okay. Yeah, so the way I configure that, I choose the results show up in both places. So it's one of the configuration. So okay, so those. So there's also other quick ways to look at data. Some of you probably have used Linux. In Linux, you can use a command called head information. In R, remember R is actually developed in the Linux environment. So the head, so R inherent many commands from Linux. So head is also a command in R. So if we use the head TB, it actually shows up 1, 2, 3, 4, 5, 6. First 6 rows of the data. But because there are so many columns, it actually didn't show up all the columns, but give you a browser window to look for the column. So you can actually see there's a white arrow. I'm circling this white arrow here. If you click that white arrow, it actually lets you go over all the columns. But what if you want to see what the head can do, you can actually look for the header information. See how you can control the header information. It also tells you how many rows you can control. So, and instead of header, there's also another command or function related called tail. Instead of looking at the first few rows, you can also look at the last few rows. Right? So tail. So instead of head, I can change that to tail. That will be looking at the last few rows. So that seems to be something in Wyoming. Look like Wyoming is alphabetic like this last stage. So the first state is Alabama. So okay. But what if I don't want to look at all the rows of the, I only want to look at a few columns. So we can actually use, this is so-called subsetting. So here I'm looking at the just column 2 and 3 and first 2 rows. So there. So you have to pay attention here. There is a comma. There is a comma to specify the column there. 2 column 3 from. What if I say column 9? Actually, column 9 to 15 and first 2 rows. Because there are so many, it actually gave me a browser again. So, well, I don't want to say that. I'm going to look at the 9, 10, 15. How about that? And then I should be able to see all the colors there. So, it's actually, that's just latitude, longitude, and the date. Yeah. So. And this is actually also shows the where that the first column of cases start with. So, and so I think that started with the 12. I think that started with the 12. 9, 10, 11, 12. Yeah. So the 11 will be the combined key, which is a unique key we can use. So, and later on, we're going to use that as what? Row name, because that's a unique key. We can use that as the row name. How many columns? Well, based on the GUI interface, we see there are 342, but we can also find out how many columns by use this command, the length of the word, first row. What I'm trying to do here, length of the first row, and then that basically is how many columns. Okay. So what I then do is print it out in a a readable information, they are paste them there and then print it out. So in this case, there are 590 columns. That's correct. If we look on the right-hand side in the browser, there are also 590 columns there. So. Now, there's one problem with this data set. If you remember on Excel, when we often to do data analysis, we often to do the case by every county, right? By location. We don't want to look at on the Excel, remember when you input the data, each column usually is for one data set. But for some reason, the Johns Hopkins data set, each row is for one location. I don't understand why that's the case, but this is what we end up with. This is just this data set is. So if we want to, and also in R by default, each column is a variable, remember? So if we want to use R to analyze this for each county, then we have a problem here because each location is a row and that's not how data frame is designed for. So what we need to do here is so-called, we need to do in matrix is called transpose. What we need to change every row into a column. This is basically what we need to do. Now, if we change every row into a column, there's also another problem because in data frame, every column has to be homogeneous. But here you have a character, and then you have the cases, right? So those are not a homogeneous data set. So in a way, if we want to convert this into our data frame with every column homogeneous, we cannot use the entire input data. We have to truncate it. We need to leave those character information out and only use the cases number. So this is, so in a way, this is good exercise to show you we have the raw data, but it's not directly usable when we try to use R to analyze it. But we can so-called pre-processing the data or cleaning the data. And clean seems to be a very tedious word. In fact, for data science, if we say clean data, nobody wants to do it. So we want to say data wrangling or data pre-processing. That seems to be a bit more neutral word. Yeah. Sure. So here, what I want to do is I rotate the data frame so that the data in each county is in one column. This is basically what we want to do here. And this is how we are going to use the tidyverse dplyr select function. So we are going to select from column 12 all the way to the end. So in tidyverse, everything is piped. So it's percentage greater than, this is just like the pipeline. So we have the table, if we ignore that, that's just an assignment. So my table is TB for short for a table. I like short names, right? But it cannot be short. If I say T, that's a bit confusing. TB table is good enough. So, so TB going to do what? I need to select the columns 12 to the last. Why I select 12? Because the first case, January 22nd, that's column 9. I'm going to select from column column 12 to the last one. After I select, I treat that as a matrix. Okay. And then I cannot use T because the T in R means what? Transpose. T, what is the T in R for? T actually stands for transpose in R. It basically put every row as column, every column as a row. but you can only do that on the matrix. So T is also reserved the keyword in R. So you cannot use T to represent the other things. But transpose, so this is, if I go back to my code, it's multi-interact. Yeah. So I select 12 to the last row, and then I put this as a matrix. And then I transpose this matrix, and I put it back as a data frame, as the data frame. So basically, the first code, we have a matrix. Okay, so the first one, we have a matrix. Oh, I need to assign this back into TB1. So I assigned it a different variable called table1, TB1. So it'll be different from the TB, and you won't override itself. Oh, someone has a question?
So what are the dimensions of that matrix? Which ones are the rows and which ones are the columns?
I'm sorry, I didn't hear your question. What are the dimensions? The dimensions are what are the dimensions? You can look at the TB1 once you. Oh, I see.
Okay.
Yeah, there. So, this is actually pretty large matrix now. So actually, it's actually still not considered the big data, even though it looks big.
Like, is the 12 for the columns or for the rows? On line 95?
So no, before you are doing this, this is basically, okay, I think I'm going to call it TB1A, this one TB1B, so you can actually see what are the difference there, right? So I'm going to call that TB1A. So there, TB1A, you will see the dates are still on each column. TB1B, no, then the dates are in every row. Does it make sense? So the first line is just, it's basically taking all the data from the original data. It's just the cases number. Everything is still the same, it's just as a matrix. The second one, the line 96, I'm doing a transpose.
Okay.
For transpose.
So is 12 for rows or columns? 12 to length.
12 to length, that's column. Select a command, you only select a column.
Okay.
Yeah, so if you look for, you have to look for specifically which selector for. Okay, so select column, subsetting column. Yeah, only select columns.
Okay.
This should be part of a tidyverse basic usage on the data account. So the select command only works on columns. So this is subsetting columns using select.
Okay.
Yeah.
Thank you.
Yeah. Okay. I think I need to put it back. Otherwise, the following code is going to have trouble to run this. Okay. Hopefully that's all I changed. So okay. So now we actually can tell TB1. Now we can actually see there. So those are actually all the way to yesterday. So it's pretty update, right? So and then so those are the dates and how many columns? Now we have 3,342 columns, basically locations in the US. Well, which one is Hamilton County, Tennessee? That's a good question. What do you think? How do we find it out? if you just look at the column, go back to your GUI to look for it, that would be a bit outside tedious. Just right? So, and besides, we are doing data science. We're supposed to do something more smarter than that, right? So, okay, so that's a question we need to find out, right? That's the task we need to complete. So, okay, so we now need to add some meaningful name to the column, right? If we still look at the variable 1, variable 2, variable 3, that's very confusing, right? So if we add, say, Hamilton County, Tennessee, oh, then we know, let's pick this column, right? So we need to add some so-called meaningful column name. So this is the next task, add a meaningful, sorry, my typo, add a meaningful column name. And then we can actually easily subset it. But what is the meaningful column name? That's really the art. In this specific case, in this COVID-19 data set from Johns Hopkins, this meaningful data name, column name, it happened to be this combined key. It had a county name, state name with the US. It's okay. I mean, we don't have to remove it. But with the county name and state name, that's sufficient to name every column. So we are going to use that as a column name. Remember, this is when it's coming input, it's all in the combined key. We're just going to use the combined key for the transposed data as a row name. So this is, we are going to, and this can be done using a function called names. Names by default is actually names column names. Names of the object by default for the data frame is the column name. So in this case, if I run names.tb1, right now it doesn't mean anything. It's just variable 1, variable 2, all the way to variable 3000 something, right? It's really not helpful. And we want to change that name into what? Combined key. We're going to replace, basically, replace column names with a combined key.
But how would you know if the column corresponds to the right data?
That's how we transform this, right? Because we take the TB1 from the original table. All we did is just change every row into the column. So the order doesn't change. We use exactly the same order. And good question. So we didn't sort or reorder the original data. We use exactly the same order. So, good question. So, in fact, you are not sure about it, you can index it to verify it. So this is, we rename it, the column, and then let's check this. There, we're looking at the first, actually, we don't have to look at first 10 column, first 2 column, that's good enough. Right, so August 22nd, Augusta, Alabama, cumulatively, if you look at this, it's increasing. So this is the cumulative cases, 8,000, 1,100. Oh, but Baldwin, Alabama, this is probably has much larger population, 31,176. This is a lot, almost 4 times more. So there. So now this column name is much more meaningful, right? So okay, if you want to look for Hamilton County, Tennessee, now what should we do? The question is, let me see. The next question will be, now if we want to look for Hamilton County, Tennessee, what should we do? So let me add a question. Whoops. Because I increased the font, I have a very small space to work at. So the question is, how to find Hamilton I hope I spell it correct. If I have a typo, obviously it's not going to work. So, yeah. Not actually. So let me see how many people answer. Very good. And some of you actually did correct. This one actually missing, I think, missing a comma. Although for tibble, it probably also work. This is because not only work if it's a tibble, but I believe this is data frame. So I think this is a data frame. If it's a classical data frame, it won't work. If it's tibble, it actually works. So it's a bit confusing. You really need to know what you are working on. Yeah, tibble is the more recent version, so it's a little bit more smarter than the old data frame. So we're going to what names did I use? TB1. So I'm going to say my location, and I'm going to say just look at the 100 to 105 days. Oh yeah. Now the question, I'm not sure whether that's correct or not. So I'm not going to do that. I'll just say tail. Wow, how many county has 50,000? That's shocking, isn't it? Can someone Google see how many county? What's the cumulative cases? Oh, I see. It's probably not easy to find. Now, good thing is it has been 0 for the last 3 days. See, there. Although it's actually not good news because last 3 days is just Friday and the weekend, so nobody worked on it. It's actually doesn't mean there's 0 case. It just means it's a weekend. Nobody worked on it. Nobody decided to report the cases. Yeah. So again, that's actually data analysis. So you see the data, what it means is a different thing, right? Data doesn't tell you what it means. But when we look at the data, you need to really think about this is a Monday. Yesterday is Sunday. Nobody actually in the county government are probably working to report the data. So we see 0 cases, doesn't mean it's really 0. It's just nobody put the number there. So okay, well, we actually can come back and check this. For now, that's a question. That we found out that Hamilton, Tennessee, that's a lot, but comparatively, actually, probably not that bad in the US, hopefully. No. Now, this is actually another issue. Actually, I have 15 minutes, so let me see how much. I'll try to finish the dates. So the dates is a very special data type in computer language, not just R. Because if you think about, we have January 30, January 31, January 32. No, there's no January 32, no January 33. It becomes February 1, February 2, and then February 28, February 29. Well, sometimes it has, sometimes it doesn't. So, and then you go to March 1. Then, right, this is not like 1, 2, 3, you just count. It's a very weird data type. So if you, in fact, on Windows, sometimes you sort by date, you realize you have a trouble, right? So you have 1 to 9, and then 10, it doesn't go to 9, that goes to 1 again because you sort by the first letter, right? So if you sort by, so right now the date is what, in text format. So if we want to do a plot of the time series using the text form of a date, that would be a very bad idea. Right, so we need to actually using the so-called computer science date as the object to actually plot that one. So in R, we actually have something called Luber date. Someone just come up with that name. Apparently, that's the faster converting of date, like you oil change or something. So Luber date is the package we can use to handle the date object in R. So for those who haven't used this, you need to install that package. So if you go to Tools, Install Package, and then if you just type Luber date there, that's Luber date. You can install that one. So, but I have already installed, so I'm not going to do that again. So if you now Luber date actually, if you Google, there's a really almost like several dozens of commands you can use how to manipulate the date object. One of the objects called MDY. This is because in the United States, also special. In the rest of the world, they often use date, month, and year. In the United States, we use month, date, and year. And in fact, at one time I made a mistake going to a different country. I put I habitually put month, date, and year, and my input was rejected. You cannot have like the month, if you put it wrong, you cannot have a month more than 12. So yeah, so apparently MDY is the command just to deal with the United States conversion. So MDY, month, date, and year. So this should give me October 1st, 2020. So there. It actually automatically converted into year, month, and date. Apparently, that's by default the R version of this. Yeah. So now it's converting into a so-called correct date time object. So we happen to use this Luber date to convert all the text data into the actual date. And that actually, all those data is basically column name. That column, all the data has a column name from the first 12 to the last. And we can check. Those are all what? Characters. Those are text. We need to convert all those text into the object. And basically using what? Oh, sorry, I wrong the probably bad idea. And then we just use the MDY to change that. When we change that, now is actually into what? A year, month, and a day. That's converting into the day. So all we need to do is just use MDY on all those current dates and then assign it back the data, the column. And that would be the object there. So, yeah. So, oh, I see. That's also the last column. So let's see, TB1. If we go to the last column, there, dates. Yeah. So we put this dates now as the object. So it's actually, well, the first day the US started collect the COVID cases is January 22nd, 2020, and all the way to yesterday. So there. So once we have the date of the object, and then we actually do something called select the time window, order the date. So in this case, I'm going to select a time window from March 30, 2020 to May. Actually, maybe I think we closed it on March 15 something. Let's change that to March 15. And then see how what I did here, in this case, I use a filter. Remember, we first use select. Select is for column. Filter is for rows, for applied conditions. So in this case, I apply the table 1, which is have the dates. What I want is the date is greater than March 15, 2020. I can only do that because I use the NDY. Otherwise, this greater than sign will be just alphabetical order, right? So I convert this into date. I'm going to pick the date is greater than that, and also smaller than May 16, and then just look at the header information to double check it. March 16 to actually, oh, I see. This is too long. So if I use a bit smaller, and then we can see it. 20. How about this? Then we can just see the result without the there. So apparently it's the because I didn't pick the equal sign. If I use the equal sign, then you will see the borderline as well there. 315, March 30. Right? So this is without the looper date. Picking the time window will be very confusing. I'll just say that, right? So with the looper date, now we can do a time window pretty easily. So, okay, so we actually can pick passing the data using a time window. You can have a starting date with the number of days. Like if you want to pick 1 month, have the starting date. Remember, very often we say we are going to look at a 2-week sliding window to see the cases. Then we decide how we are going to open, close, mask on, mask off, or whatever, right? So if we with this, now we actually can do a sliding window to see how the case works, right? So in this case, I'm doing a 30-day sliding window. I have a starting day. For some reason, I picked December 15, 2020, and then the ending date will be that day plus 30. That will be a 30-day window. If I want to change a 2-week window, I just change that to 14, right? So if I change that to 14, that will be a 2-week sliding window. And then we filter greater than that, less than that, and just select the fifth column. I'm saying the first 2 columns because of the monitor, I cannot see many columns. So yeah, so there. And this actually just, there are more rows, but I'm not looking at first 2. Let me change that first 7 days so I can actually see everything. There, all 7 days are there. And then that's the 2 columns of that time window. So this is quick way to do a time window analysis. And now we can actually also plot a time window. In order to do the plot more easily, I first subsetting the data set. So I again filter within that time window. I'm going to a 30-day. It's a 30-day time window, and then I only select the first 5 columns. And then we use a ggplot to do the time window plotting. So the ggplot use the aesthetics plus geometric plus smoothing operation. So this ggplot is something called additive plot. It's almost like 3D printing, but this is the additive plot. So we first plotted the baseline, the data information, plus a geometric. In this case, it's just a scatter plot, and then add a smoothing function. So let's see how it works. By the way, I'm plotting the column 3. So there, this is the 3rd column of the data we just take, and the time window from December 15. Oh, this must be 1 month. Did I pick 1 month? Yeah, 30 days. This is a 30-day window, and this is for the 3rd column. Third column is what? Barbour County, Alabama. So there. So now we have a cumulative case plot for Barbour County, Alabama. And this is it's not pretty because you see the column name is not really meaningful, right? So, but later on, we are going to work on how to make a pretty or presentable plot. So, okay, I have finished my objective. I finished the chapter 1. So this is chapter 1. So if you go back to your R, minimize this, I finished chapter 1, COVID-19 transmission data. We explored a chapter. The next chapter 2 will be converting that cumulative cases into daily cases. And in fact, you can actually run, as a preview, I guess, you can run the entire code. Just put this into HTML file. It's going to take a while because there's many rows and the columns are there. And you can actually see it at the bottom, it is running. And then that will be, I forgot which country is there. I didn't put a country name there. So, chapter 3 will be the Google model, overlay with the Google modality. So. Okay, questions for today? So the review, our learning objective, again, load tabular data into, from a CSV file into a data frame, and then manipulate the data frame. This will be indexing, subsetting, select column, filter the rows. And we also converted the date into the actual object, from the text into the object. And then we also use ggplot to visualize the data. Oh, someone actually Googled, found out. Hamilton County 51,523, 141 days. That seems to be similar to what we see. It looks like the data is not updated on the Johns Hopkins data. It looks like, I guess, the Hamilton County Health Department has more updated data. So, yeah. Or maybe it's just Johns Hopkins people didn't work on the weekend. So, yeah. Okay. Very good. Thank you. Okay, if I go back to my Socrates. Okay. I'll just let you sign in. Oh, here. So I'm going to go back to the first, let people sign in. So there are still 6 students haven't signed in. So. Um, 25. Oh, okay. There are 20. So you look at some students already dropped off. Okay. Well, I don't really use this for the grading. It's just used to gauge student engagement, so it's okay. Okay. And so you can actually review and go through the exercise for chapter 2, chapter 3. So when we meet on Wednesday again, you will be more prepared. Besides, on Wednesday, we will have 2 more data points. You can go back to see whether that 0 is true or not. In fact, if you think about on the weekend, Friday is 0, 0, that means those cases are just cumulated and reported on Monday and Tuesday. So usually on Tuesday or Monday is actually a peak, and then it goes down. On the weekend it becomes zero. So this is the COVID data have this. If you really do a periodic, then you will see the cycling, weekly reporting cycling, which is shouldn't be there, but it is there. So yeah, but it just reflect human habit of working. So, okay, I'll see you next time then.
Oh, Professor, real quick. Do you mind reposting the GitHub thing, the zip file, just so I can get it on the computer?
Oh,
yeah, like how you got to the zip file and then you put it on the R studio.
I see. It's linked inside of this here on the canvas.
Oh, I thought you linked it through the actual chat, or I guess you just.
Yeah, I put it on the canvas side. It's not. It's inside of canvas.
And it's just the R studio set up the prompt. That's the same thing.
It's the same thing. Yeah. Although the zip file is old because I don't update the zip file every day, right? So yeah. So but if you download the zip file, there's one thing you have to do manually on R is the Google Mobility. It doesn't update automatically. You have to download the file and zip it.
Okay.
But the Johns Hopkins data it's updated in real time. So.
All right, I can figure that out.
Yeah.
Thank you.
I'll see you next time.